So that's minus 1 over 5, integral from minus 2 to minus 7. And here you have u to the power minus 2 du. Yeah, u 1 over u squared is u to the power minus 2. Let me erase this thing now and we will continue. Equal to minus 1 over 5. Well, integral from u to the power minus 2, it's, you remember, 1 over minus 2 plus 1, well, which is minus 1. So kind of, let's put here 1 over minus 1. And u to the power minus 1, which is 1 over u. And from minus 2 to minus 7. Let me erase this intermediate things. So that's equal to, well, minus 1 over 5 and minus 1 is plus 1 over 5. And here is 1 over 7, so minus 1 over 7, minus plus 1 over 2. That's the answer. Now, if you want, you can simplify it. But when you are doing web work problem and you kind of, let's say you have to compute some integral and you come here, well, put this in web work like this. Don't simplify, kind of. Again, you can do this. You can simplify if you prefer. But if you put the answer like this into the web work will accept it. Of course, assuming there's no mistake. Yeah, so it's quite often, it's a good idea just not to simplify. Just you put the answer like this. So even later when you look for the mistake, it's easier to find the mistake. Maybe kind of this is the same, but maybe you have to correct something on the here and so on. So that's one example. Let's do one more. Let's say we try to compute integral from 1 to e ln of x over x. Now, of course, we do computation in a moment. You can think what this means, kind of. Yeah. So let's say if you try to draw the picture, let's say here is x, here is y. Well, let's draw this function. Well, so kind of x ranges from 1, so let's say 1 here, and e is here. And then you try to, let's try to draw this function. If x is 1, we have ln of 1 over 1, ln of 1 is 0, so the function is a 0. And if x is e, we have ln of e, which is 1 over e, so 1 over e. 1 over e is more or less 1/3. So this is more or less here. This is 1 over e. And the function looks more or less like this. So what this means, this is this area. We are trying to compute this area. The interpretation of this integral is this area under this curve. Okay, so now let's do computations. Let's compute this area. Well, substance that will work is u equal ln of x. If u is equal ln of x, du is 1 over x dx. And you see that this is du. So the integral becomes, let's continue here, integral. Well, eu du. So it's nice, easy. But again, let's look at the limits now. Yeah, you know, limits are common mistake. You put one from 1 to e. Limits usually change. So let's see what are the limits. If x is equal to 1, u is ln of 1. What is ln of 1? Who knows?
0.
0, yeah. So the lower limit is 0. And if x is e, u is ln of e. What is ln of e?
1.
Okay, so let's erase this, and I put the limits are from 0 to 1.
No.
Not too early. The second one. If x is 1, u is equal ln of 1 reaches 0. And if x is e, u is equal ln of e, which is 1. Okay, so the limits are from 0 to 1. So of course, the answer is 1 over 2 u squared from 0 to 1. You see, you don't have to come back to x's, yeah? Just we are happy with u. And then if you substitute, that's 1/2. 1/2 minus 0. So this area here is 1/2. You can think if this kind of is roughly speaking correct, then you see that you can, well, that's kind of okay. Maybe you can estimate this blue thing. So this blue area, that's blue. What is this blue area equal to? Well, it's equal to 1 over e minus 1. See that that's more than 1/2. So kind of that this one looks reasonable. Yeah? Check it, use your calculator if you want, and so on. Kind of. So okay, if you have the rough approximation, okay, let's say if e would be 3, that's of course that would be 1 over 3 times 2. So see, so this blue area is 2 over 3, roughly speaking. So of course, it's reasonable that this looks that that's 1/2. Of course, that's a very rough approximation. Use your calculator to get a better value, yeah. But the blue area is rough approximation to the blue area is 2 over 3. If you approximate E is 2.7. If you approximate this by 3, you get 2 over 3. So sometimes it's useful to make this thing to see if you didn't make a mistake in your computations and so on. Okay. So this is, now let's go again to slide.
No.
Yes.
2, 3.
Okay. It's okay?
I have a question.
Yes.
So what with the A, is that the area?
Yes.
What exactly did you do there?
You mean this blue area?
Yeah.
No, you see, so the blue area is this rectangle. This, and this. So what is the area of the rectangle? It's this times this.
Oh, you just okay.
Yeah, this
But
is 1 over E, and this is E minus 1.
but the 1/2 is the actual area.
No, 1/2 is actual area of this black one.
Okay.
So you see, if the area, blue area is roughly speaking 2 over 3, so this means that, yeah, it looks reasonable. So this black area is 1/2. That's all it is. That, yeah, it looks like the answer makes sense. Okay, so let's continue. So we have something that is called integrals of symmetric functions. Now, when we finish this thing, I will go and solve some problems on web work. So we will be discussing web work in a moment after we finish this theoretical part. So integrals of so-called symmetric functions. So situations like this, we have that f is continuous on the symmetric interval from, you see, from minus a to a. And we have two cases. If f is even, well, you should know what's even function. Here's the definition. Even function means that f of minus x is f of x. The typical example of even function is cosine. Cosine is even function. For example, tangent is even function. No, tangent, no, the cosine. Tangent is odd function. So f is even means f of minus x is f of x. And if function is even, and if you have to compute integral from minus a to a, f of x dx, you compute integral from 0 to a and take it twice. Here is the interpretation. Even a function looks like this, that this part is just the reflection of this part. If this is a mirror, that's a reflection. So, of course, this area here, this and this, is this area twice. So kind of that's more or less obvious if you kind of look at this picture. But this simplifies computations quite often. Yeah, if you have even functions, usually it's easier to compute from 0 to a than from minus a to a, because when you substitute 0, that's usually an easy thing. It's easy to substitute 0. Usually there's a lot of zeros. And second part, if f is odd function means that f of minus x is minus f of x. Again, typical example of odd function is sine or tangent. Yeah, those are odd functions. And for odd functions, if you compute the integral from minus a to a f of x dx, is just the 0. No computations are needed, just 0. The interpretation is this, that of course, graph of odd function looks like this. Think about that, that's part of sine. Then that's a positive area, that's a negative area, they cancel each other. So the answer is just 0. And that's quite useful. So kind of just if you may have complicated integral function here. If you observe that this function is odd, you don't have to compute anything. The answer is 0. Well, kind of you have formal proofs of this. Maybe let's look at the formal proof of part B. Okay, formal proof. So integral from minus a to a, you split it from minus a to 0 and from 0 to a. You leave this like it is, and you compute this making substitutions that u is equal minus x. If you make the substitution and change the limits of integration, you see that this will be minus from a to 0 f of minus u du. Now, if you change minus u into u, and then if you exchange the limits, so integral from a to 0 is minus. If you get from 0 to a, you will get plus. So you get this, then you see from a to 0 is minus from 0 to a, this and this cancels, you get 0. So you have a formal proof, but again, it's easier to see on the picture, kind of. The picture is here. If you want, try to kind of understand all the details and so on, kind of, there's enough information here to understand this. But, so here are some examples. Well, integral from -2 to 2, so symmetric interval, x to the power 6 plus 1 dx. Well, you see that that's even function, of course, yeah. So because that's even function, you can compute from 0 to 2 and take it twice. So it's not finished, but of course, it's easier to compute this than this. And look, this is nice. From -1 to 1, tangent x 1 plus x squared plus x4 dx. Well, very complicated function, and probably there's no way to integrate it. However, if you make the observations that this function is odd, well, then you don't have to compute anything. The answer is just 0. Yeah. So that's the odd function. Tangent x over 1 plus x squared plus x over 4 is odd function. Maybe let's show this maybe precisely, just in case. I will share this. Stop and let me comment again on this example. So, okay, so look. So function f of x is tangent x 1 plus x squared plus x to the power 4. Well, let's compute f of minus x. Well, it's tangent minus x 1 plus minus x squared plus minus x to the power 4. Well, so tangent minus x is minus tangent x. So that's equal to minus tangent x 1 plus, of course, minus x squared is x squared. And minus x to the power 4 is x to the power 4. So you see that f of x is equal to minus f of minus x is minus f of x. Yeah, so this function is odd. Well, function is odd. If function is odd, you don't have to compute anything. You can conclude right away that the answer is 0. Yeah. So you will have such problems on the web work. So kind of keep this in mind. If you cannot really, if you see that it's really too complicated to compute, maybe you can take advantage of this symmetry here. Yeah.
Professor?
Yeah.
I have a question. For tangent x, negative tangent x divided by 1 plus x squared plus x to the 4th, how do you know that that's odd?
Because well, this is what we have here. F of minus x, look, f of minus x is equal to minus f of x. Exactly. Look at this once more. Look at this relation here. So f of minus x is equal to minus, I keep this minus, and what is this? This is exactly f of x. So we demonstrated that f of minus x is minus f of x, and that's exactly the definition of odd function. For even function, f of minus x is equal plus f of x. For odd function, f of minus x is minus. So that's this line proves this.
Okay.
Okay, let's go to web work. There's a lot of web work problems in this section 5.5, and that's kind of, we'll maybe look at some of them. So let me share the screen again. And I will try to go now to web work. So let me, well, it's here already. No, not web work. Web work, ASU, EDU. Okay. And you see my web work courses. Here is my name. And we are in web work. So you see it, I hope. You see here the introduction to web work is still open. It closes, so make sure you do this introduction to web work because it will close tomorrow at 10 p.m. So if you didn't do this yet, do this. This is basically free credit. Yeah. So kind of do this thing. But now sections 5.5 is open. It will close on September 2nd. You see that I already opened 6.1, 6.2. But that's what we have today. So you see we have a lot of
Could we go over number 22?
Okay. You want to start from 22 right away? Okay, let's see. Okay, if you want 22, let's go first to 22. Let me have to move things. Okay, so let's see. A lot of problems. Yeah, 22, fine. Well, find the average value of the function. So maybe let me remind you what's average value. And to remind you this, maybe I will use the whiteboard. Okay, so that's the repetition. Let me first remind you what is average value. So let me stop share. You had this in calculus 265, so you need to know the definition of average value. So here, that's the picture. You have some function defined from A to B. Let's say that's how it looks. It doesn't have to be positive, but let's say that's how the function looks like. And now, what is the average value of this function? So average, let's call it EVA. Definition of average value is the following. You compute the integral from A to B f of x dx, and you divide this by 1 over the size of the interval, so b minus a. So this is definition of average value of the function, okay? And now, once we have this, I will probably use the whiteboard again in a moment, but let me go now to this 22, and we will see what we have to compute. So again, share the screen. So find the average value of the function. So basically what you have to compute the integral, cosine to the power 9 3t, sine 3t dt, and integral is from 7 to 10. And then once you compute this integral, you divide this by 3, because the size of this interval is 10 minus 7. As a matter of fact, there's a solution here. I'm instructor, so if I click here, there's a solution it's written. Again, I can see the solution. You will be able to see the solution after you submit the problems and the problem will close. So here you see again, solution. The average value of a function f on the interval AB is f average. Okay, so is 1 over b minus a, integral from a to b, f of t dt. So the average value for this function is 1 over 10 minus 7, integral from 7 to 10 cosine 9 3t sine t. So of course here to solve this, we substitute for cosine 3t. If u is equal to cosine 3t, du is equal to minus 3 sine 3t. And then this integral becomes minus 1 over 3 u to the power 9 du. You compute this, and that's the thing. So minus 1 over 30 cosine to the power 10. And then you divide by 3 because that's in the definition. And that's the answer, kind of. Yeah.
Thank you.
So kind of somewhat tedious. Now, I am discussing those problems. Probably your problem has somewhat different data. But of course, the idea probably is the same. So I think each student has somewhat different problem. So that's problem 22. But let's go and kind of just comment on a few problems. So let me go to let's go to the beginning. Okay. So again, each of you will probably see something somewhat different. So again, let's discuss some of them. Maybe I will sometimes just kind of use a solution. Sometimes I use a whiteboard kind of and so on. So here you have integral 6 sine square root x over square root x dx. You may have maybe 8, or you will have 7 or 10, or maybe instead of sine you will have cosine. Yeah, but the problem will be similar. So here they suggest, well, even they suggest the substitute for u equals square root x. Then of course du is 1 over 2 square root x dx, 1 over 2 square root x. So I need 2 here. So I need, so instead of 6, I will have 12. And this will become minus 12 integral sine of u du. And that's minus cosine, and kind of that's the thing here. Now, you were asking me for this feature check answer. You don't have the feature check answer. I can check answer, and I see that that's correct. You don't have this check answers, but there's no big deal if you submit the answer. Let's make the mistake. I will, let's say, put here, instead of minus 12, let's put here minus 2. So let's make the mistake, okay? Because that's incorrect. And I submit it. Well, the answer is incorrect. If you see this, you can go back and then you can make another attempt. Okay, now let's correct it. And I will submit it now. Well, it's fine. So you see, you can, as long as you submit the correct answer at the very end, you'll get 100% of credit. Yeah, your overall record score is 100. Your score was recorded. You have attempted this problem 8 times. Well, 8 times because I was playing this when I had previous class. I was playing this. I had no classes, so I attempted the problem 8 times. I got the right answer at the very end, and I have 100%. So you have unlimited number of attempts. So don't be afraid to submit the answer which is incorrect. If it's incorrect, you can always correct it later, and you get a full credit anyway. And I don't look at this thing at all, how many times you attempted. It doesn't matter for me. Okay. So let's check So I'll be just commenting maybe on some of them. Sometimes I use the solution, okay? So here, so they make, or they suggest x5 minus 9 to be u. So here is the solution, kind of. You see, I'm instructed, so here, so you see, this is this with the substitution. So kind of this is 1 over 5 du is this thing. So kind of this is this, and then kind of you can integrate, and the answer is here. So of course there's some computation. Again, you'll have somewhat different numbers than I have here, yeah, but 3. So again, probably there's no substitution suggested, but it's easy to guess that you should substitute for x to the power 9. U is equal to x to the power 9, so du will be equal to 9 x to the power 8, and you will be able to annihilate. You put here 9, 1 over 9, and then you have 1 over 9 e to the power u, so it will be 1 over 9 e to the power x to the power 9. So that's what's written here. Correct. So here again, you substitute for, there's no substitution, but u equal ln of x, and then you'll be able to annihilate dx over x will be du. So if you make substitution, so even in your head you can solve it, yeah? So it will be integral u cube du. So that's 1 over 4 u to the power 4. So that's 1 over 4 ln to the power 4. That's what's written here. Of course, solution is here. Now, so 1 over 4 ln x to the power 4. So if you solve all those kind of 24 problems, you should be absolutely kind of fluent with those things. And here, of course, substitution, you make u equal 10 minus 7x. This will solve the problem. U equal 8t plus 9. This will solve the problem. Of course, there's some technical details. Yeah, there's kind of some, you see, so here there's still, you have to kind of play around. Yeah, that's the correct answer. Yeah, but that's substitution you are making. Yeah, u, as you see here, u is equal 8t plus 9. So here probably 5 plus square root plus x to the power 5. Maybe you can substitute for square root as well. I don't know. Let's see what they suggest. Yeah, just 5 plus x to the power 4 is a substitution. And then, so again, there's some technical details, of course, on each problem. So here, of course, in order to solve this problem, you have to know, well, that the derivative of arctangent is 1 over 1 plus x squared. So if you substitute for arctangent, you'll be able to eliminate 1 plus x squared. So u is equal arctangent, and then du is dx over 1 plus x squared. So this thing here will be, so you see, after the substitution, you'll get integral u to the power 7 du, so which is 1 over 8, u to the power 8. So arctangent to the power 8 over 8. Yeah, that's probably correct. So here you make substitution of u equal 2 over x will solve the problem. U equal cosine, and then you have to know the formula. Integral from secant square, that's something you have to know, that's tangent. So the formula we will need later is that integral from secant square is tangent. That's the formula you have to know. So certainly kind of just, we have to know some formulas. Here you have two parts. This one you split in two. So this integral is 10 plus 9 e to the power minus x, and you substitute for u equal minus x. So that's how you solve this. This one you make substitution right away. U equal e to the power x, or u equal 10 e to the power x plus 9, even better. Yeah. Again, substitution does not have to be unique. Here you split into two pieces. Of course, you know what's the integral from sine, and you remember the integral from tangent. We got this last time. Integral from tangent is ln absolute value secant. So you have to use some formulas, and so on. Here you probably substitute for cosine, you will be able to annihilate sine. Here probably you can substitute for x squared or maybe something else. Let's see what they suggest here. Yeah, they do x squared, yeah. So if you substitute for x squared, you will get u squared plus 1, and you will be able to annihilate this x here, yeah. Anyway, so there's 24 problems. You have time until September, and maybe let's stop at this time. So we are exactly on the schedule. I finished section 5.5. So next time, if you want to read ahead, look at section 6.1. It's on Canvas already. If you want to read ahead, watch some videos if you want. So next time we will go to section 6.1. But that's, I think it's enough for today. Thank you. I will stop share, and then I will end the meeting. So thank you very much.
Thank you.
See you next time.
Thank you.
Mhm.
Have a good day.
Bye.